Okay, so we were talking about tank monitoring. We're going to jump right on to pipe monitoring. And this can be a little bit more confusing. However, the handouts that I had in the back, this will address, the handouts will have a lot of the detail that I'm talking about as we go, so you can follow along with that. Okay, so once again, I based these designations on installation date. So we have your single wall piping. I'll discuss monitoring alternatives and construction with those tanks. I'm sorry, piping. Double wall piping that was installed before July 1st, 2004. And then your double wall piping installed on or after July 1st, 2004. And like I said, when we address the post July 1st, 2004, we're going to be talking about tanks and piping. So single wall piping, you have your option, you have pressurized piping, you have your emergency generator system piping, and you have both options of pressurized or a suction system for single wall piping. You have conventional suction piping, safe suction piping, that's not necessarily an emergency generator system, and you also have gravity piping. Okay, so first we're going to discuss the pressurized piping, but I'll be referring to this this source right here, and this is what's on the handout that I gave you guys, and this is a wonderful resource, and it's found State Water Board website, and we chose to print this one because it is such a valuable resource. Okay, so like I said, this can be found on the Water Board website, and this gives you an overview of the types of systems that I was just listing. And I'll address each one separately. I've highlighted these items because within these options, or I'm sorry, these types of systems, it's going to address, it's going to talk about automatic line leak detectors. It's also going to address 0.2 gallon per hour monthly line test, 0.1 gallon per hour monthly, or I'm sorry, annual line test. So I thought I'd define those before we move forward for any of you that are not as familiar with these items. Okay, so automatic line leak detectors. They shall be installed on underground pressurized piping and shall be capable of detecting a 3 gallon per hour leak rate and must either restrict or shut off flow of product through the piping when it detects a leak. Here we have an example of a mechanical line leak detector, and a mechanical line leak detector is going to restrict, so that meets that requirement. Or you have your option of a PLLD or ELLD, either one, electronic line leak detector, or it's also called a pressurized line leak detector. And this type of line leak detector is going to shut off flow of product completely. So when it restricts, you can still, like when they do the functionality test during your inspection, you can actually have them pump fuel, and you'll notice a very obvious decrease in pressure and volume when you have the restriction. If your PLD is working correctly, you're going to get an alarm at your monitoring panel, and you're not going to be able to pump any fuel whatsoever. Okay, and then all the regs reference the need or the requirement for a 0.2 gallon per hour monthly line test or 0.1 gallon per hour monthly line test. So I'll tell you what those are, just so we're all familiar. It needs to be done, the first one, 0.2, it's not as stringent, which is therefore why you need to do it more frequently, and that shall be done at least monthly at any pressure. And the monitoring method shall be capable of detecting a minimum release equivalent to 0.2 gallon per hour leak rate defined at normal operating pressure. 0.1, that's going to be more stringent, but yet less frequent. So the leak rate is equivalent to 0.1 gallon per hour. Like I said, that's going to be done annually. And that can be done at a pressure that's designated by the equipment manufacturer. And like with anything with USTs, a lot of times when we have any questions or doubt, we often turn to manufacturers' recommendations. Ultimately, they're going to know what's best for their product. So let's see, this method shall be capable of detecting, like I said, that 0.1 gallon per hour leak at 150% the normal operating pressure. Okay, so I had that schematic, which you all have a copy of too. And I'm going to go bit by bit so each one is clear. And the first subcategory would be the requirements for pressurized piping. And don't forget, until I tell you otherwise, we're going to be addressing strictly single wall piping, okay? So with single wall piping, you're required to have an automatic line leak detector. Don't forget, it needs to detect that 3.0 gallon per hour leak. And the automatic line leak detector shall be capable of shutting off the pump when a release occurs and shall shut down the pumping system automatically. Also, if it fails or is disconnected. So if it needs to shut off the pumping of product completely, what is your option? Can you use a mechanical line leak detector? No, because that's simply going to restrict flow. So single wall pressurized piping, you're forced to use a pressurized line leak detector. Okay? In addition to that line leak detector, you're going to need either a 0.2 monthly or a 0.1 annually. So overall, you have two options, or not two options. You have two requirements: line leak detector and a line test, whether it be monthly or annually. Okay, before we get into the details of emergency generator tank systems, let me explain what that is, just so we're on the same page here. It's going to be a UST system that provides power supply in the event of a commercial power failure. It stores diesel fuel and is used solely in connection with an emergency system, a legally required standby system, or an optional standby system. Okay, so you need to meet this definition in order to qualify for the monitoring requirements for the emergency generator single wall line requirements. And here they are. I'll go into detail. Also within emergency generator category, you can have an emergency generator piping that's pressurized, and you can also have emergency generator piping that's suction. I've seen both, but let's talk about the pressurized one first. So you're going to need to have an automatic line leak detector that detects a 3.0 gallon per hour leak. Okay? Don't forget this is pressurized, but the difference between a pressurized emergency generator line versus for example, a retail site, the line leak detector only needs to be connected to an audible visual alarm. It doesn't require a positive shutoff. Why do you think that is? You probably don't want your fuel supply being cut off during an emergency. So it still requires that stringency of a line leak detector, so you have your continuous monitoring, but you're able to use a mechanical line leak detector as your option. So just like the previous pressurized systems, you're going to need either a 0.2 monthly or a 0.1 annual line test. So line leak detector and line test. And then you have the option of having a suction system that's also in conjunction with your emergency generator tank system. Okay, and with a suction system, and I'll go into some detail about suction systems in the next couple slides, but you're going to need a 0.1 gallon per hour line test. And that only needs to be done every 3 years. And then you're going to also be needing to keep a log of daily or monthly visual monitoring. And what you're looking for is any air in the line in the suction systems. So you don't necessarily have to have any equipment with this suction piping. You could have a line leak detector for the sole purpose of doing a line test, or you can just every 3 years have a contractor who's certified come in and do a third-party line test every 3 years. Okay, so like I said, I'm going to discuss some suction piping. You have conventional suction systems, and you also have safe suction systems, which I'll talk about in detail in just a minute. But for conventional, it's going to operate at less than atmospheric pressure, and there's no submersible turbine sump, okay? And this system has either a foot valve, and that's located in the tank, or an angle check valve, which is located at an elbow in the piping outside of the tank. And I have a visual to show you this. So the top little red circle is going to show you the angle check valve. And like I mentioned, it's outside of the tank, whereas the foot valve is in the piping within the tank. Okay, monitoring requirements of single wall conventional suction piping. Every 3 years, they're also going to need the point 1 and the daily visual monitoring of the system looking for air in the line. So single wall conventional suction has identical requirements as a suction system for an emergency generator tank system. Okay, and what are you looking for? Daily, you're looking for the presence of air in the line, because that's going to indicate a problem or perhaps a breach in the line. So here are some indicators of air in the line. You're going to have your display wheels on the meter skip or jump during operation, so it's not flowing evenly. You might find that the suction pump is operating, but it's not pumping fuel, or it might pump fuel very sporadically. You might have it going fast in the beginning, and then it slows down as it begins to pull liquid. Or you might hear a rattling sound in the suction pump, which is never a good thing when you hear that anywhere. But it's going to also indicate some sort of air and liquid mixture. So that was conventional suction. Safe suction piping is a little bit different, because with this design, there's no foot valve, there's no check valve, there's nothing to keep fuel in the line. That's the big difference. That's why you're going to find, when I get to the monitoring requirements, it's less stringent. It seems to be risk-based, where you have the conventional system has foot valves and check valves. That's going to maintain fuel in the line. So with no check valves, you're always going to have the fuel drain back to the tank. It's never going to be caught behind these valves. Okay? So if there's a leak, it's always going to drain back into the tank, and it's less risky. And here's a visual. You're going to have your check valve closest to the dispenser. It's not even below grade, not near the tank, and you can see that there's free access for anything to drain back into the tank. So monitoring requirements, really no requirements. I mean, safe suction is probably the safest type of system you can have. But of course, you want to make sure that your criteria is always being met to be considered a safe suction. So you also want to be operating at less than atmospheric pressure. Your piping is sloped, so that's going to fall back to the tank, of course, and it's not going to be tripped up by any valves or pumps that are below grade. And if you do have a check valve, it's going to be directly below and as close as practical to the suction pump, and that's generally right at the dispenser area near where the shear valve would be. And then you want to do the inspections to make sure that these requirements are being met. But I don't think there's any sort of log requirement, but just, for your own sake, to maintain your criteria. Okay, how do you know if you have a safe suction or conventional suction system? I mean, you might look in the sump and you see the same types of piping and configuration. But if you want to verify safe suction, you're going to loosen that access plug just below the shear valve, which is, I believe, the same place where you might tie in to do certification of your leak detector. Line leak detector. And you're going to listen for a sucking sound. And if you do hear this sound, it's going to indicate that product is draining back into the tank and that there's no valve present in the line that's going to block that flow. However, if you remove that access plug and you have product sitting right there and it starts seeping from that access point, you know that you have a conventional suction system, because it does not drain back to the tank. And here's what a suction system might look like, from a tank top. And there's no indication of safe suction or conventional suction just looking at it from here. Okay, and last but not least, you have your single wall gravity piping. The only requirement is you're going to need a 0.1 gallon per hour biennial line test, and then biennial being every 2 years. Okay, any questions on single wall piping? Okay, so I'm going to get started back on double wall piping. Um, this is one of the more common things that we see in the field. So I did want to say this for after lunch so we could spend a little bit more time on this and not rush through. So similar to single wall piping, I've broken it down into sections so we can address each type individually just to make it a little bit easier. Our sections include pressurized piping, double wall piping that's associated with an emergency generator system, suction piping, and gravity piping. Here's some visual examples. On the left-hand side, you have your double wall fiberglass piping, and on the right side, you have double wall flex piping. And I'll admit, from the outside, flex piping, you can't tell if it's single wall or double wall just by looking at it. So at that point, you start to rely on dates and install plans and that type of thing. And I know some companies, depending on whether they're single wall or double wall, they have different colors for their pipe. So those are just some examples when you're not quite sure. Then if you notice, you can tell it's double wall fiberglass, and this is the A.O. Smith brand, that they have those blue clamshells right here. So that's something that's part of the secondary pipe. And then you notice this one in the middle is going to be a single wall pipe, and this is the coupling you'd find with single wall. Okay, so just by looking at that fiberglass piping picture, does it give you any clues about the install date? So you have a combination of double wall and single wall piping, so most likely this was installed before which date? What year? July 1st, 2003. Because don't forget, and I'm not even sure about this, but I don't know if that's going to be the vapor line. So if the vapor line is still single wall, you know it's a pre-2003 install. Because otherwise you're going to see clamshells on every single pipe. So just some more clues, you know. And once again, the installation date becomes very important to determine monitoring. Here's just a close-up of how secondary piping will look in the sump. You have your piping penetration up at the top there. So you're going to have your double wall portion of the pipe and single wall come through that penetration. And then this 3-inch pipe is going to be the secondary containment for the primary piping, which is usually a 2-inch in this type of application. And then Zoraida will discuss secondary containment testing a little bit later. However, this test reducer boot is what gets pushed back onto this portion of the secondary pipe, which will help you isolate that secondary line when you do that test. And when you're not doing the test, this boot needs to be pulled back to allow access of any leaks to come through that secondary pipe. Yes?
Does it have to be pulled back in the UDC instances?
They should be. It's not the low point, but we request that they are. Oh, I'm sorry. He asked, do the test boots need to be pulled back in the UDCs? I think it depends on the type of pipe, if possible. What do you guys see in the field? Oh, is it not? Sorry, I haven't been in the field in 4 years, so apparently it's not always pulled back.
So I think the reason is because if it's pulled back at one point, which is either the sump, it leaks back into the sump.
Right. But I'm going to actually disagree with that, only because we've had situations where the flex piping, it still needs to drain into that sump, the UDC. Because if everything goes back to the tank sump, then you're not catching it at the earliest opportunity.
Because some of the contractors are selling it to us like that, if it's okay to be on UDC as long as it's not in the sun. So they're longer.
And that might be,
Contractors are doing that.
yeah, and the reason this stands out is we had a situation with some flex piping, and to make it easier to test the secondary, they wanted to keep the loop closed throughout all the UDCs and not have any sort of outlet into the UDC, and we didn't allow that with the flex piping. And the reasoning was for them was for access for testing, but the problem with that is it didn't allow for the earliest opportunity to discover a leak.
Was that next to the violation? The notice of the county?
Uh, At least for the flex, yeah, I haven't seen how it looks in the dispenser in a while, but so we're trying to determine, and I need a little help here from all you guys just because I'm not super familiar with this, but the question is, this shows a sump, which is going to be the low point of any system with the test boot pulled back. So if you're looking at a UDC application, are you going to have the test boot pulled back? It's not the low point, but in some situations we were talking about that for flex piping in the past we've not allowed, it's hard to, without showing a description, but with, and I don't know how familiar you guys are, but with the flex piping, they can connect between the different, the jumper cables exactly, or not jumper cables, jumper tubing. So basically it keeps everything closed. So if you have a leak in the secondary within flex piping, it's not going to have an outlet into the UDCs. It's going to go back to the sumps. So the question was, fiberglass piping, do you have to have the boots pulled back within the UDC? And I'm finding out from field inspectors that most of the time with the fiberglass they're kept on. Yeah, I think at least in San Diego the flex becomes more of an issue in the UDC specifically.
As long as it's double piping like those, you're okay if you have it on at the UDC.
Oh.
Well, the reason I'm asking this because we have situation at some of our stations. It's kind of with some inspectors it's okay, and with some inspectors it's not. When we go back to our contractors, they always tell us that as long as it is as long as it's off in the sump, which is the point of it's going to bleed back to, we should be okay. Because if you check them off at the UDCs, and some of these test booths are very hard to reach. In order to do the test the next time that comes around, you have to remove the whole dispenser and put all these boots back on. It's costly and it's cumbersome. So my question is again, if we leave it on UDC, should be okay? And it's not going to be a violation to you guys when you go out there and look at our sumps and UDCs?
Oh, I would say that depends. Or Steve, it is a gray area. And I think if an inspector marked it as a violation, they would be in their right because of that portion of the regs that talks about detecting a leak at the earliest opportunity. However, I don't know that everybody would necessarily mark that as a violation, at least for fiberglass piping. But you're right, that's why people do that, is because you don't have the access as easily, and oftentimes you have to take the dispensers off to reach those boots, and it does become costly. The same scenario, we came up with a compromise between us and this other company where they weren't able to keep a loop to keep it connected, to have these jumper tubes to keep it all connected, but they could have basically extender tubes that could reach up and above grade so they could access it that way, and then not to keep anything like a Schrader valve in the end. So it's still locating the dispenser, and it's still going to deposit any leak in that dispenser, but it still allows the accessibility for the testing contractor when they need it. But if a Coupa gives a violation, I think they have a leg to stand on, but I don't think every Coupa is going to look at that. This becomes more of the noticeable issue, at least. So, but at the same time, I would listen to your Coupa inspector in terms of following the regulations and the law as opposed to contractor, because you're going to be the responsible party. So So did I confuse everyone even more?
Oh, no, you.
But that's a good question to throw back at you guys. What do you see in the field? Those of you who've been around for a little while, do you see the boots left on in the UDCs, or do you see them pulled back, and how do you handle it? No one gonna volunteer? In the UDCs? It's hard to remember how the UDCs look because we're always very focused on the sumps because it is the low point. Right.
So then if you had a spill, you wouldn't know until it was completely full. If the strainer valve's on the very bottom and you take out the strainer valve, it will leak into the sump and you will detect it at the low point at that point.
That is true.
And we have
But if that can be pulled back, I know we request that it be pulled back, even though that makes sense.
and correct. And a lot of ours we pull back after testing because the test boot is not really part of the system. But that's a whole nother issue.
Right. I mean, we could probably argue this back and
But
forth.
what we do with ours on the generator, we pull them back after we test them and they're open. But the ones that are hard to get to, we take that strainer valve that sits on the bottom and take it out. And then it's at its lowest point.
And you guys have seen that Environ piping where the coupling stays on sometimes within the sump, and then they have the tubes coming out. And as long as that Schrader valve, and I'm speaking from our personal how we do it in San Diego, and it might even differ between inspectors, but at times, if that tubing's left on for the Environ piping, and you can verify that there's no Schrader valve or ball valve at the end of that small line, that's not necessarily a problem either. Because the thing with flex piping too, and why it's not as much of an issue as leaving something like this on the fiberglass, is that secondary, that interstice of a flex pipe is so small that it creates any sort of leak, in theory, is going to be shot out just because of the pressure of that interstice since it is so small. So that's where having that tube is not going to necessarily cause any more delay in finding that leak. So that was our rationale in San Diego. Any more comments or stories from other Koopas about this? No? Okay. Anyway, so this is how a typical sump might look. There should be a sensor right over there as well. So imagine that that's there in the low point. And by low point in a sump, you want the sensor on the side that the piping is actually going to exit the secondary pipe. But just to show you a basic system, and then the next slide has a little schematic of what happens when there actually is a leak. So you have your double wall tank, and then there's your secondary pipe, and you can see the penetration goes into that sump, and you have the simulated leak from the primary. So the purpose of that secondary pipe is not only to protect the backfill from the leak, but it's also to act as a conduit for that leak to go into the sump, which is why you have the sump sensors. So the sump sensors serve two purposes. They're actually monitoring any leaks within that sump, such as a leak from the turbine or a leak from that primary part of the line. Often we call it that kind of the primary transition pipe. But it also is monitoring any leak you find throughout the whole piping run. As you can see, everything at installation, you're verifying that piping is sloped down to the tank pad. So any leak along that run is going to fall to the tank sumps. Okay, and similar with the single wall pipe, here's the monitoring requirements for double wall piping installed pre-July 1st, 2004. Once again, this is the same source, and this is part of that handout. And this gets a little more complicated, so at any point, stop me if you have questions. Even though it makes sense, when you see it written out like this, it doesn't always make sense. So we can stop and talk about anything you guys need to talk about. So probably the most common scenario you see is double wall pressurized piping. And once again, this is before July 1st, '04. Post July 4 is going to be, or '04 is going to be a whole nother story.